Hello everyone. Today we are going to solve the next question. So the question is product array puzzle. We are given an array nums of size n, and we have to construct a product array p such that p of I is equal to the product of all the elements of nums except num of I. Okay. Suppose the given example test case is 10, 3, 5, 6, 2. Okay. So what we have to return except the current element, the multiplication of all the other elements. Okay. So here it will be 3 into 5 into 6 into 2. So it's 180. You have to return 180 for the first element. For second element, we have to multiply 10, 5, 6 and 2. So 10 into 5 into 6 into 2 is 600. Again, except 5, we have to multiply all other elements, that is 10, 3, 6 and 2, and the multiplication is 360. Similarly, we have to do for 6 and for 2 also. Okay. So the first approach, the brute force approach or naive approach, will be use two loops, and let's say I is from 0 to n, and j is from I plus no j is also from 0 to n, except like what we have to do, I'll show. Let's say for int I equal to 0, I is less than n, I plus plus, and again for int j equal to 0, j is less than n, j plus plus. Okay. Except the current element, that means if I is not equal to j, then we have to multiply. Let's say if I take multiplication, initially it's 1, ml equal to ml star. Okay. What num of j. Now we will get the multiplication except the current element, and that we have to store in an array. The answer of I equal to 10, and we have to return this answer. So this is a naive approach. We using two loops, but what we have to the expected time complexity is O of n. But if we see this thing, we are using two loops, nested loops, so our time complexity is getting O of n square. Okay. So we have to optimize this. So the second approach can be first find the multiplication of all the elements and divide it. So what we can do is, let's say initially I found the multiplication, I calculated the multiplication. Now we have equal to 10 star 3 multiplied by 5 multiplied by 6 multiplied by 2. So we have the multiplication of all the elements. Now what we have to do, answer of I will be multiplication divided by nums of I. Okay, so this is our multiplication. If I want the first element of output, what is this 180? It is a multiplication of all the other elements in an array except this first element, right? So what we have to do, we have the total multiplication. We just have to divide it by 10, then we'll get this output. Okay. So this is one of the approach, and here we also have to consider the element. So here you can see nums of I can be 0 to 200. So the element can be 0 also. Okay. So in the last case, we don't have to worry about 0, as we are calculating the every like all multiplications using two loop. But in this case, we are dividing the nums of I. But it can be 0 also. So we have to check that condition also. If nums of I is 0, if the current element is 0, so also here what we have to find, if the current element is 0 and all other elements are non-zero, then we have to calculate again the multiplication of that except that 0. Okay. So here if it was a 0 instead of 2, if it was a 0, I have calculated only this much. So except 0, and also I will calculate the count of 0. Let's say count of 0 is 1. So our array elements are 10. 3, 5 and 6 and 0. So my multiplication is 10 into 3 into 5 into 6 into 0. So if my count is greater than 0, okay, that means I'm having 1 0 like like more than 1 0 or 1 0 in an element, in an array. Okay, so the multiplication of all other elements in an array except this number will be 0, right? Right. So here what we have to check, if the current element is non-zero and the number of zeros are greater than 0 or greater than 1, then we have to put in the answer we have to put it as 0. And if the count is not 0, and then we have to put the multiplication. Okay, so this is the second approach. Then the third approach is, as in the last video, the last concept video, we have seen the prefix sum concept. So here what we are going to do, we have to find the prefix multiplication and suffix multiplication. So I'll first tell you how we can do it. This is our array. So what I'm saying, in prefix sum, what was the formula? Prefix of 0 is equal to error of 0, and prefix of I was prefix of I minus 1 plus AR of I. This was our formula. So now here for multiplication, the first statement will be the same. The next formula, our formula will be prefix of I equal to prefix of I minus 1. Instead of plus, we have to do multiplication AR of I. We have to find this. So for our example, our prefix array will be 10. 10 into 3 is 30. 30 into 5 is 150. 150 into 6 is uh, 900. 900 into 2 is 1800. Yeah. So now, so we have to also find the suffix array. So we have seen the question equilibrium point, the point at which the left subarray sum and the right subarray sum should be equal. So that time we have also calculated suffix array and prefix array. Here also we are going to calculate the prefix array and suffix array. What we are going to do, except this element, we have to find the multiplication, right? So for the first element, the all other elements are on the right side, but if we see the third element in an array 5, we have two sub arrays. Okay, what we are going to find, we are going to find the multiplication of sub arrays. So 10 into 3, and then 10 into 3 into 5, then 10 into 3 into 5 into 6. Okay, so for the left part we are going to see the prefix array, and for the right part, for multiplication right part, we are going to see the suffix array. So if we see the suffix one, I'll also write the suffix formula. Suffix of suffix of n minus 1 will be AR of n minus 1, and suffix of I equal to suffix of I plus 1 multiplication multiplied by AR of I. So this is the formula. So if we see the suffix array, it will be from right side. If we check, initially it will be 2, then 6 into 2 will be 12, 12 into 5 will be 60, 60 into 3 will be 180, and 180 into 10 will be 1800. So this is our prefix array, and this is our suffix array. Okay, so what we have to find is, except the current element, we have to return the multiplication of all other elements, right? So here if we see, this is the current element, except this, on right side we have to find the multiplication. So except this element, on right side we have this. Okay, this is the multiplication of all other elements on the right side of 10. So till this point we have this multiplication, right? 180. So for the first element, So what we have to calculate, let's say if we consider the 5, for 5 index, at index 5 we have 115 60. It is included, okay, 5 here, 5 is included. So for that, if we till 5 we have multiplication 150, okay, from left side. So we have to exclude 5, so just go back by 1. So this is the left multiplication of 5. And for right, then you go right, like next, by 1. So here it will be 12. So 6 into 2 is 12, and 10 into 3 is 30. So now if we see for element, for num of I equal to 5, our prefix, the left multiplication is 30 and right multiplication is 12. Now we have to do the multiplication of both. 30 into 12, that will be 360. So if we see here, we get 360. Similarly for 6, for element 6, what we have to do, one back and one next. So for this index, back is 150 and next is 3 2. So 150 into 2 is 300. So here you can see 300. And for the last element, we don't have the next suffix, right? Because it is a last element, we have to find the multiplication of all this. So we only have to see the prefix, okay, 900. And for the first element, we only have to see the suffix 180. So in this way, we can find the our desired answer. So I'll write the code. First, what we have to do, we have to find the prefix and suffix array. So here the data type is long. So I'll take the long prefix equal to new long n. For int I equal to, okay, so I equal to 1. Initially what we have to do, prefix of 0. What is prefix of 0? It is nums of 0. I is less than n, I plus plus, and prefix of I equal to prefix of I minus 1 into nums of I. Now we have calculated the prefix array. Now we have to calculate the suffix array. So suffix equal to new long. So initially suffix of n minus 1 will be nums of n minus 1. Add suffixes from back, prefixes from front. For int I equal to, not 1, I equal to n minus 2. Okay, I is greater than or equal to 0. So we are tracing from the back. I minus minus, and suffix of, what, suffix of I equal to suffix of I plus 1 multiplication multiplied by nums of I. Okay. So suffix of I will be, this element will be multiplication of this element and the current element. Okay. Now we have our prefix array and suffix array. So if we also here, what we have to check, if we see here, you can see the constraint n can be 1 also. So if the element with the size is 1, let's say our okay, here if the element size is 1, example can be the first element will be, let's say, 12. Then the element except this, the multiplication of element except this will be 1, right? So what we have to do is, initially only we have to return an array, right? So I'll take one array long with size n. If size n equal to 1, then we have to return, first we have to insert at first position as 1 multiplication, and then we have to return the answer. Okay, that is the array. Now here, if the size is more than 1, that is 2, then we know for the first element answer of I is answer of I. So here, okay, here you can see the answer of I will be multiplication of all the elements on the right side, all the array. So it will be what? Suffix of 1, suffix of 1. And answer of n minus 1, the last element will be all the elements before this last element. It will be then prefix of what? Prefix of till this. That means prefix of n minus 2. Right, prefix of n minus 2, yeah. So now for int I equal to 1 to I is less than n minus 1 I plus plus. So here answer of I will be prefix of 1 back I minus 1 multiplied by suffix of 1 next I plus 1. Okay, now we have to return the answer. So this is how we have to solve this question. Okay, so yeah, we have to return. I just forgot the return keyword. Okay, here you can see um, the element. If you check with the example test case, okay, you are getting the output. Now, if you check with the this element 2, 12, and 0, the second example, yeah, you can see it is working for the test cases. Okay, so this is the optimized or efficient solution. And also one thing, I also given an D-Shaw interview. So in the interview, technical interview, they asked me this question and they were expecting this solution using the prefix and suffix concept. Yeah, thank you.